Okay, 35. I kind of got it set up here a little bit for you here. The blue graph is f prime. Okay, so, and we want to draw it's going to be a red graph that is a continuous function whose derivative is f prime. And it has to go through this point here. F of negative 3 is 0, so when x is negative 3, the y coordinate is 0. Well, at this point, and this is actually an exercise we're going to do a lot of in the next couple of weeks actually, when x is negative 3, y is 0, but what's the slope at that point? The slope is, well, this is the derivative at negative 3, the slope is 1. So I know the slope's going to be 1. So I'm going to draw a little piece of my slope right there. When x is um, 2, when x is 2, what's the slope going to have to look like? When x is 2, the slope has to be 0. So what does my graph need to look like at that point? Well, I don't know how high or low my graph is, but I do know the slope has to be 0. And then at 1, what's my slope going to look like? My slope's going to be at negative 1. So it might look like something like that. My slope at 0, my function doesn't have a slope. The slope is non-existent. Okay, now what does that mean, non-existent or undefined? That means it might be like come down and be at an angle or something like that. So it looks like my graph could be something like this. Come up and down and maybe hit somewhere down here at a point. Now, okay, we'll leave it at that. And we're just kind of getting a rough estimate. Now, does that make sense for this section? My red graph is a parabola, and the derivative, if it's an x squared or quadratic, the derivative will be linear. Okay, that's reasonable. Now on the right side, we got to pick up from here. Immediately to the right of it, my derivative is negative, and then it goes up to a 0, and then it's a positive. So what's happening to my slope immediately to the right of this point here? Well, here it's a steep negative. To the left of 0, it's a steep negative. To the right of 0, it's a negative, but it's not quite as steep. Right? It's not as big a negative number, so my graph is not going to be as steep. So it's going to maybe come off a little bit less steep. And then at say 1/2, my slope is negative 1/2. Okay, so it's going to be more like maybe negative 1/2. And then at 1, my slope is 0. Then it turns positive, and it's going to turn around and go like something like that. Does that make sense? So if I draw it on a separate picture over here, it might look something like this. It hits this point here on the axis, and then it's an angle shot, and then goes up like that. So it's not smooth at that point because the derivative doesn't exist. In fact, the slope as it approaches from the left side, the slope is negative 2. Delta y over delta x is negative 2, and the slope from the right is negative 1. Excuse me. Does that make sense? Because here's the slopes. They're getting closer and closer to those values, according to the blue graph. All right, does that make sense? Okay, 36 says connecting f prime, and f double prime. Function is continuous on 0, 3, satisfies all of these things. Find the extrema, sketch any points of inflection, sketch a possible graph. Well, I think we should probably, let's go there. Sketch a possible graph. Let's sketch the graph, and maybe these other things will come out along the way. So let's do that. I'm going to erase this over here, and so we can get some space here. In fact, I'm going to go ahead and delete this here, which will probably permanently delete it. Well, that's all right. Okay. So we got lots of room to work on here. Okay. So we go this route. I'm just going to look at values. We're talking f values, 0, negative 2s, and 3s, and so forth. So if I'm going to do this. Okay. So f of 0 is 0. F of 1 is negative 2. F of 2 is 0. F of 3 is 3. Okay, so we're looking at something like that. Let's look at f primes. F prime at 0 is negative 3. So I'm going to draw my little slope. It's pretty steep right here. Okay, it's negative 3. F prime at 1 is 0, so it's going to be flat. F prime at 2 does not exist, and F prime at 3 is really steep. Okay, F double prime at 0 is 0. Okay, so possible inflection point there. F prime of 1 is 1, so it's going to be concave up at this point, right? F prime at 2 doesn't exist. F prime at 3 is 0, so that's a possible inflection point too. So I'm going to write little i's here at possible inflection points. So let's look down here, what we got down here. From 0 to 1, F is negative, F prime is negative, so it's decreasing. F double prime is, so it's concave up to here. Between 1 and 2, the function's negative. F prime, I'm looking over here at these guys right now. F prime is positive, so it's increasing and it's concave up. And from 2 to 3, they are all positive. Okay, oops, I hit the button. Okay, so we've got a situation right here though. This point right here, what's going on at that point? We know the derivative doesn't exist and the second derivative doesn't exist. There's got to be some sort of little angle thing going on or something at that point. What could that look like if it comes down? It's concave up, but then it's still concave up. Could it be something like, could it do something like that? Absolutely, where it still comes up and it's concave up, hits that point, concave up, it's increasing. So at this point, this graph probably looks something like this. Okay, so absolute extrema where they occur. This is going to be an absolute max up here at x equals 3. Absolute minimum at x equals 1. Relative minimum x equals 0. Right? Possible inflection points. These are possible inflection points I wrote at the end. I don't know if they are because I don't know what happens, if it changes concavity there and there. And sketch possible graph. There you go. Okay, does that make sense? Okay. All right. Not that you can say no and I can answer you or anything like that, but if you have questions, talk to me about it in class.